Inverse functions, here we go. Inverse functions are actually very easy. Basically, what you're doing is you're switching x and y. You're switching the input with the output. So, if I give you a function f of x where we have these values, 1, 2, -2, 3, and -4, 6, to find its inverse, all you have to do is switch x and y. So, f -1 of x, which stands for the inverse of f of x, would be 2, 1, 3, -2, and 6, -4. So from here, all you have to do is graph them, and you can see what it looks like graphically. So I have the original f of x plotted here, and if it helps you to see it, we can actually connect the dots. And what we're going to do is we're going to graph 2, 1. We're going to graph 3, -2. And we're going to graph 6, -4. And if we were to connect those dots, you can see that an inverse function is just a reflection over the line y equals x. And that's because we're just switching x and y. The only thing that's changing is x becomes y and y becomes x. That's what inverse functions are. So, keep that phrase in mind. We're going to find the inverse of f of x. So f of x is given. Now you know that f of x is basically a replacement for y equals 2x plus 3. F of x is just function notation. So to find the inverse, all you have to do is switch x and y and then solve for y again. So we have x is equal to 2y plus 3. Now solve for y. Subtract 3 from both sides. So we have x minus 3 is equal to 2y. Divide both sides by 2, and you get y is equal to x minus 3 all over 2. If you would like, you can simplify it to x over 2 minus 3 halves. It does not make a difference to me. So your final answer would be f -1 of x is equal to x minus 3 all over 2, and that's it. So again, all you're doing is switching x and y and then solving for y again. In the next example, this is y is equal to x cubed. So you switch x and y and you get x is equal to y cubed. How do you get rid of a cube? You cube root both sides. So all you're going to end up with, the cube root of x is equal to y. So we write our final answer. Inverse of f of x is equal to the cube root of x. That's it. That's all you're doing here is switching x and y, and then you have to solve for y again to get what the actual function is. So here's 2 more. You get to try these 2 on your own and see if you get the correct answer. Give them a try. So here you go. On the 3x squared plus 7, technically you have a little mistake here, and that's the fact that there is a square root in the denominator, but for now we're not worried about that. So you would just leave it as the square root of x minus 7 all over 3, and you're good to go. The purple one was a little bit of a challenge, and that's because you had to FOIL. So you have to remember, whenever you square both sides and one side has 2 terms, when you group them together and square them, you have to FOIL. And then you subtract your 7, divide by 2, and you end up with your final answer right there. So that's it. So one other thing to do is, this is a question where it just says, is f of x an inverse of g of x? So what you want to do is find the inverse of g of x and see if you get f of x, and if so, then the answer is yes. If not, then the answer is no. So it's asking, is f of x an inverse of g of x? So what you do is you find g of x, so y is equal to x plus 2 over 5. And now we solve. We have to switch our x and y. So that's going to give us x is equal to y plus 2 over 5, and solve. So how do you get rid of a 5 in the denominator? You multiply both sides by 5. So you get 5x is equal to y plus 2, and subtract 2 from both sides, and you get 5x minus 2 is equal to y. So that's going to tell you that g -1 of x is equal to 5x minus 2. Does that match your f of x? The answer is yes, it does. So the answer is yes. That's it. That's inverses. Basically, the phrase of the day is switch x and y, and then obviously you have to apply it however it asks you to apply it. That's it for now. This is Longo. I'm out. See you. Bye.